Hi everyone, we're going to take a look at performing a one within, one between subjects ANOVA. So it's a factorial ANOVA where you have two different independent variables, and one is a within subjects variable where you have two or more conditions where the same subjects are tested more than once or two or more times. And then you have one independent variable where it's between subjects, where you have two or more groups. Say you are comparing males and females, correct? And then you are also comparing these independent variables to, or using these independent variables to determine the scores or the outcomes on some dependent variable, which is a continuous variable. All right, to perform it, we're going to do this in SPSS, and you simply select analysis, general, linear model, and then repeated measures. So let's go ahead and do that. And before we begin, we'll just give you a short explanation of what kind of data we're looking at here. For us, we have gender. Zeros are males and ones are females, and we're going to compare they were weighed at different points in time because they were being tested on the effectiveness of how well a particular diet was working, and so they were weighed over a period of time. We're going to use the last four weight measurements to make our comparisons, and so we would go to Analyze, General Linear Model, and then repeated measures. Okay, so you can see here we start out with they want us to let it know what is the within subject factor, and that would be the weight, because it's the same people being weighed over a period of time. So we're going to name it weight loss, and we have 4 times we're going to compare. Oops. Also, you can't have a space or anything like that for the label. So if you put an underscore, it'll let you add it. So you can't have any strange characters or spaces. All right. So now that we have that in there, you can hit define, and we're going to tell it what are the 4 comparisons or within subjects that we're looking at, and that would be this one here through there. And I did that by highlighting the first one, holding down the shift control key, and then clicking on the last one so they would all select at the same time. It's a nice little keyboard shortcut. And then it wants us to indicate the between subjects factor, and for us that's going to be gender. And now we want SPSS to produce plots, so we can sort of get a visual of what's going on here, right? And so we'll do it 2 different ways. First, let's get a plot where gender is displayed for the horizontal axis, and the weight loss measures are displayed with the lines, right? And then just click add, and then we're going to do it the other way around, just to see, how it looks, how it changes. And then add, continue. And typically, if your between subjects factor has more than 2 levels, you would perform post hoc tests, so you can tell which levels are different from the others. In this case, we only have 2 levels, so we wouldn't perform a post hoc test for that. And then click on the means, and we want to get a look at, we want to display the means for the gender and weight together and produce simple effects. So we would need to know this information if there is an interaction between our 2 independent variables. So click continue, and then click options, and we want descriptive statistics, estimates of effect size, and homogeneity tests. And then click continue, and then click OK. All right, so first box tells us, what are the within subjects factors being compared here, and it's our weight variable, and then it indicates the number of people in our between subjects. So we have 9 males and 7 females. And then it gives the descriptive statistics for both of them together. So within the first time they were weighed, it gives us the mean for the females or the males and the females, and all the descriptive statistics for each one of those categories. Then it gives us another test for equality of covariance matrices. You do not want to see a significance here. The threshold here is 0.01. We did not meet that, so we qualify for this assumption. And then we're going to move into the test for sphericity, and this is another normality check. And this is another test. We don't want to see a 0.05 or less significance level, and we don't. So we can safely assume that our tests are normal, or our data is normal. And then here is where we're looking at the main effect for weight loss, as well as if there are any possible interactions between weight loss and gender. And since our sphericity is assumed, it wasn't significant up here, we would look at the first row, and we see that there is a significance. And by the way, here are the effect sizes for weight loss, right? Going down to the interaction variable, we see that there was no significance here. And you can see it corresponds with effect size. It's very, very small, right? And now let's go down to our between subjects, and here is the normality test for between subjects, and we don't want to see any significance here either, and we don't, so we've passed that test. And here is the test for between subjects, and we go along here where it says gender, and we look for significance, and it is 0.05 or less, so that is a significant outcome. And our effect size is given here. And then we can see in the next boxes, if we had a significant interaction, we would want to take a look at these outcomes here to see if there were any simple main effects. And so that would tell us if there was significance where we had, the weight loss one group between males and females and so on. Even though these are flagged as significant, we wouldn't take these into account because our initial test for an interaction effect wasn't met. It was not significant. And you can see another pairwise comparison, and it's just another view of the same thing. So here you can see weight loss for each weight loss time that they were weighed, then the males and females. But here it's looking at the males and females with each time they were weighed, right? And now we can see our graphs. And here is where the lines represent the weight loss times that they were weighed, and the x-axis represents the gender, right? And you can see females were much lower than males, and that makes sense. Males typically do way more than females, and you can see the weight loss as they were weighed over time while they were on their diet. You could see it was dropping, right? And then here is a view of the plot where the lines now represent the gender, and you can see the difference between the males and females this way. But if you're looking at them across, you can see they do slightly start to trend downwards as they were weighed, right? Both groups. All right, so now that we've looked over our outcomes, you might want to put this into a report in APA format. And the way you would report this type of test is maybe something like this: a mixed design ANOVA with gender as a between subjects factor and weight loss as a within subjects factor revealed a main effect of gender. And then you report the F test, right? And here you would find it, and this is just copied from that outcome, and you would report the F, right? With the degrees of freedom. So there was two groups. So if you say n minus 1 for the total number of groups, that would be a 1. And then you have 2 groups minus the total n. And there was a total of 16 people in this study. And so 16 minus 2 would be 14, right? And then here's the F statistic, 42.15. And rounded, it would be 1/6. And then the p-value and the effect size. And then you would continue for the next main effect and for weight loss, which was significant. And here we had 4 groups, so we were n minus 1 for that, but it's a within subject, so the total number of people is only -1 this time. And then you report the F statistic as well as the p-value and the effect size. And then you must state, whether that there was no interaction. If there was, you would report the same statistics as you would find here. And then you would have to report the simple main effects where we saw those pairwise comparisons. And that's how you do a 1 within, 1 between factorial ANOVA. Thanks for hanging out with me. See you next time.